Hello and welcome to another video, or I thank you for watching another video by PiPad Mathematics, and I'm Professor Lamb. And what we're doing in this video, I'm using the BrainingCamp app that deals with pattern blocks, and we're going to do a little bit with algebraic patterns, just some basic patterns, and then helping students to build a table of values and then understand a relationship between the numbers on that table of values to predict how many, say, blocks are going to be in a fifth or an eighth kind of iteration of our pattern, our rule. And I have my setting, or I have the iPad app in the settings that I prefer, which are going to be no background, opaque is the block style. You can of course change it however you please and what works best for you. What we're going to do here is I'm going to just create a pattern. I'm going to create, say, here's a green square. I'm going to put a house on top of it, and then I'm going to give it kind of a smokestack, if you will, or a puff of smoke that's going to be coming out of that. Now I'm going to zoom here a little bit and move this down just a bit. Alright, and move that down a bit. And now we're going to take our house. The second step of our pattern is going to have kind of two smoke puffs. And of course this is a very popular kind of usage of pattern blocks and pattern recognition. You've probably seen it somewhere else, so I'm just repeating it for those that have seen it before in whatever literature, and I'm showing how the app can help model that and help teach it. And so the third one's going to have three puffs of smoke. And our question is going to be, like, how many blocks are we going to use in the 10th house? So if this is house number 1, and this is house number 2, and this is house number 3, how many blocks total are going to be used in the 10th house? So I'm going to take this, I'm going to zoom it in, and there it is up in the corner, 1, 2, and 3rd house. So I want to know what's in the 10th one, way down here. And the best way to do this, or I should say, I like to say, I don't care how you get to Dallas, I just want you to get to Dallas. No matter where you live in the United States, there are different ways to get to Dallas. I'd like you to get there. So one way of getting to Dallas here is to build all the way up until the 10th house. And then you can count all the blocks. Now that works when you're trying to only get to the 10th house. But what if we said the 1000th house or the 1,000,000th house? And that's going to take a little bit more time. And that long way to get to Dallas is not going to be as efficient as we would like it to be. So we use algebraic thinking. We try to think in terms of patterns and in numbers and how they relate to each other. And one way that we do this in mathematics and organize those thoughts is we create a table. We create a table that says, you know, the house number and then how many blocks. And the house number for the first one, the second, and the third. Well, the first house had 1, 2, 3 blocks. 3 blocks. The second house had 1, 2, 3, 4 blocks. And the third house had 1, 2, 3, 4, 5 blocks. And we need to figure out how many are in the 10th block. Now, for early childhood, or not early childhood, but let's say 3rd and 4th grade, early understanding of pattern recognition and extending patterns out, we can do things along the lines of our recursive reasoning, to where we can go along this output, or the output values, and see a pattern between there. So from 3 to 4 we added 1. From 4 to 5 we added 1. So from 5 to 6 we're going to add, so from 5 we add 1 and we get 6. And then we're going to add and get 7, and then get 8, and then get 9, and then 10. That's one way to look at it. But another way that we can look at it is explicitly. How do we get from our independent, or our input value of 1, how does that get to a 3? Well, we think about this. We allow different strategies for students to problem solving this process. So 1 goes to 3. Well, we're increasing, so we can add. 1 plus 2 gives me 3. 2 plus 2 gives me 4, and 3 plus 2 gives me 5. And so it turns out that adding 2, where we take the house number and then we add 2, that's going to give us the number of blocks. And that works out great, but sometimes our input needs to be multiplied by something, or it needs to be divided by something, or it needs to be squared. And so as grades increase and patterns get more creative, we can allow students to build patterns and build sequences here, and then create tables that will then be able to be determine the explicit rules and also the recursive rules that go down the other way. And of course, now those of you that are watching this and remember in some of your more advanced kind of math classes, or even in high school where you talk about finite differences allows us to determine first if it's going to be a linear relationship where this 1 becomes the coefficient of my variable here, or it's going to be more of a kind of a quadratic or a degree of 2 type of relationship, or second order relationship. And if that's the case, then you can use finite differences in the patterns that show up there with your more advanced students. But remember, we're talking about early childhood or young elementary type learning. We want to build off of these concepts. We want to build off of this concept of drawing pictures or creating pictures, predicting how many are going to be in a latter part of that sequence, and hoping students can build tables of values and then understand patterns within those tables, meaning recursive patterns and then explicit patterns. Ideally, we'd get them to explicit because that's going to connect greatly to our functions in high school mathematics, but if not, we can stick with the recursive, and that helps build pattern recognition. So remember, we want the students to get to Dallas, and we really don't care how they get there, but we do want them to get there. So this is a quick little video about using patterns and algebraic thinking with the pattern blocks. I hope you enjoyed it. This is PiPad Mathematics, and I am Professor Lamb.